In this next section, we're going to solve quadratic equations by using the square root method. If I have a standard form equation, ax squared plus bx plus c equals 0, the coefficient of b, or the middle term, needs to be 0. So in order to solve, we need to isolate the term with the variable squared and then take a square root. Let's see how that works in example 1. If c squared minus 1 is equal to 0, then we add 1 to both sides and c squared is equal to 1. Then we solve by taking a square root. So c is either equal to the square root of 1 or c is equal to the negative square root of 1. We have to use two solutions. And you can write it as square root of 1, but then you'll need to simplify it to 1 or negative 1. And we can see that both of those numbers squared would give us positive 1. Similarly, in b, we can move the 16 to the other side of the equation by adding it, divide through by 49, and then take a square root. So r is equal to either the positive square root of 16/49, or r is equal to the negative square root of 16/49. That'll give us a solution set of negative 4/7 or positive 4/7. In C, we have a similar sort of a setup. So 5u squared is equal to 6. So u squared is equal to 6/5. That means that u is equal to the square root of 6/5 or the negative square root of 6/5. That has to be rationalized since we can't have a fraction under the radical. So we're going to change it to the square root of 6 over the square root of 5, and then we're going to rationalize it by multiplying numerator and denominator by square root of 5. That'll give us square root of 30 over 5. So this gives us a solution set, negative square root of 30 over 5, or positive square root of 30 over 5. And one last one, k squared plus 4 is equal to 0. We can solve that by isolating the squared term or subtracting 4 from both sides. Now when we take a square root, we're going to have either k will equal the positive or the negative square root of negative 4, which is 2i. So our solutions are negative 2i and positive 2i. So we'll include non-real numbers as well. All right, your turn to try. Try A. Pause the video to try that one on your own. All right, this one had a solution set of negative 5i and positive 5i. Now try B. This one gives us solutions of negative square root of 14 over 7 and positive square root of 14 over 7. Now the nice thing about the square root method is it works for equations that are in the form of some expression squared equals a number as well. So let's take a look at one of those. In example 2a, we have x minus 4 squared is equal to 9. So we can just simply take a square root of both sides. We have to use plus or minus on one side. So x minus 4 is either equal to negative 3 or x minus 4 is equal to positive 3. So adding 4, we get 1, or adding 4, we get 7. Looks like a solution set of 1 and 7. This one's really easy to check too. You can plug in 1 in the place of x. 1 minus 4 is negative 3. That squared gives us 9 in the original equation. All right, let's try B. M plus 1/3 squared is equal to 4/9. So that means that m plus 1/3 is either equal to the negative square root, which is negative 2/3, or m plus 1/3 is equal to the positive square root, which is positive 2/3. And we can subtract 1/3 from both sides. That's going to give us negative 3/3, which is negative 1. Or we can subtract 1/3 from both sides, and that gives us 1/3. So it looks like we have two solutions. Negative 1 and 1/3 are both in the solution set. All right, let's try C. C has a similar setup. 3c minus 2, the quantity squared, is equal to negative 25. So that means that 3c minus 2 can either equal 5i, or 3c minus 2 can equal negative 5i. So what do we need to do next? In order to solve for c for the first equation, we'll need to add 2, so 2 plus 5i, and then divide by 3. c is equal to 2 plus 5i over 3. And for our second equation, similarly, we're going to add 2. That's going to give us 2 minus 5i, and divide by 3 again. So solution set contains 2 minus 5i over 3 and 2 plus 5i over 3. Last one, u plus 2 squared is equal to 45. So that means that u plus 2 is either equal to the positive square root of 45, or u plus 2 is equal to the negative square root of 45. We're going to simplify that, but we're also going to subtract 2 from both sides, so negative 2 plus, and square root of 45 simplifies to 3 root 5, or u equals negative 2 minus 3 root 5. Again, solution set, you can put the solutions in either order you wish. Doesn't matter. Alright, your turn to try a few. Stop the video and try A on your own. Alright, this one gives us two solutions, negative 1 plus 3 root 7 over 4, and negative 1 minus 3 root 7 over 4. Notice that you got a common denominator there. When you took the square root, it wound up that way anyway. I've set up these so that that happens because that's going to be the result when we explore completing the square in the next video. Alright, let's try B. Try that one on your own. Here's the solution to B, negative 3 plus root 7, negative 3 minus root 7. And now let's try C. We've got two solutions here again, and you might be noticing this pattern of conjugate pairs, right? In the numerator, 5 plus 2 root 6 over 7. And in the second solution, 5 minus 2 root 6 over 7. All right, next try D. And this last one had, again, these conjugate pairs of solutions, negative 4 minus 3i over 7 and negative 4 plus 3i over 7. Well, that's it for this part.